today we're going to finish up law of sines. We did part 1, today will be part 2. Just a reminder about what the law of sines is. Okay, there's your formula for it. We went through yesterday and we proved at least the first 2 fractions, where they come from. So we're not going to go through that proof again. But we are going to just use the same formula. Remember, when you use this formula, you only use 2 parts at a time. Either the first 2 fractions, the last 2 fractions, or the first one with the last one. And the idea is you're going to be setting up a proportion. It's going to look something like this every time. And you've got 4 spots. Well, 3 out of 4 spots are going to be things you know. And one of them will be something you don't know. The thing you don't know might not be in the bottom. It might be in the top. It depends on the problem. But you'll always know 3 things, and you're going to solve for the 4th. Okay. Other than that, that's really all we need to know to look at some examples. Well, one other thing I can mention for people that weren't here, law of sines can be used to solve 3 types of problems. Anyone remember the first type? And I'm thinking of those 3 letters. No?
Angle, side, angle.
Yep. So angle, side angle is 1. Okay.
Side, side angle.
Okay, side, side angle. We're going to spend more time on that one today. And there's one more. Yep.
Angle, angle, side.
Angle, angle, side. So we'll finish off side, side angle today. Yesterday we looked at the situation where you ended up with 1 solution. You could also end up with a no solution or a 2 solution. Okay. Either one of those 3 things can happen. And then tomorrow we're going to do law of cosines. And there'll be 2 types of problems we put under that. All right, so let's look at this. So A is 6, B is 8, and alpha is 35 degrees. How can I tell that this is going to be law of sines without a sketch? Gina? We have a full row. And if you say, well, we always have a full row. You're right, we've always had a full row because we're studying law of sines. But imagine I gave you a side, side, and a side. S, S, S. You wouldn't have a full row. So when we get to that kind of problem, we'll talk about something else. Okay, but yep, we have a full row. And we have a completely empty row. And there is no possible way to find anything in that row first. You can't use Pythagorean theorem, because we don't know if we have a 90, so you can't get C. And you don't have 2 angles to add together and subtract from 180. So the last row is impossible to use, which means this is side, side angle. So when we write our boxes, what I would do is make sure you make the box a little bit bigger, leave enough room in case you have to write 2 answers. Now, when I say that this kind of problem can have no solution, 1 solution, or 2 solution, either, well, the information that was given is done. You don't have to worry about A, B, or alpha. Those 3 things were given. You don't have to do a thing with them. The only things we have to worry about are the boxes. If everything has 1 solution, then you're going to put 1 number in the beta box, 1 number in the gamma box, 1 number in the C box. If everything has 2 solutions, then you'll have 2 numbers in the beta box, 2 numbers in gamma, and 2 numbers in C. They all have to be the same in terms of the number of answers. You can't get 2 answers for beta and then only 1 answer for gamma. It doesn't work that way. They either all have 2, they all have 1, or they all have none. Okay? All right, so let's start to solve it. What do I have to find first? Yeah, can you tell me what I got to find first? Beta. Yep. So beta will be the first thing we do. Gamma will be the second. And C, that will be the last. All right, so let's set this up to find beta. So Dylan, can you tell me what I could put on the left-hand side to get this set up for beta? Okay.
Sine 35
All right.
over 6.
Yep. So there's the left, sine 35 over 6. And Devin, what am I going to put on the right side?
Would it be sine B or beta over 8?
Yep, sine beta over 8. Now we don't have to, you don't even really have to cross multiply. I mean, you can, but all you have to do is multiply both sides by 8. And that will move the 8 to the other side because the goal of this step is just to get sine beta by itself. And then ultimately the goal is to get beta by itself. Okay, let's start with the sine beta. So let's do times 8 times 8. And the left-hand side is 8 sine 35 over 6. Yes, technically you can reduce the 8 and the 6. You could make it 4/3. But honestly, when I type that in, it doesn't really matter if I press the 8 and the 6 button on the calculator or I press the 4 and the 3. If I reduce it, I'm just risking making a mistake. So I just leave it. Okay. So the left-hand side is equal to the sine of my angle. But I want just my angle. So how am I going to get rid of sine? Right? We're going to use inverse sine. Remember, we're not doing any kind of multiplication. We're just going to take that entire number and plug it into the inverse sine function on the calculator. Hit enter. See what we get. Alright, so let's type that in and see what happens. Okay, so we got inverse sine of 8 sine 35 divided by 6. If you want to type it in all at once, that's how you do it. And we did not get an error. So that means we have a solution, 49.886. We now have to check if there's a second answer. Right, but let's start by writing that one down. And that's for beta. So beta 1. Well, actually, we don't know that there's 2 answers yet, so I'm not even going to write beta 1. If there's a second answer, I'll call it beta 2. But for now, we can just call it beta, and if there's a second one, we'll label it. Okay. What do I do with this 49.886 to see if there's a second answer? Yeah?
You subtract that from 180.
Yeah, subtract 49.886 from 180. And if there's a second answer, it's 130.114. But what I have to do is see if it fits. What angle were we given? Yep. We were given a 35. Can you fit 35 and 130 in the same triangle? Yes. This time the second answer didn't come out to a big enough number that it wouldn't fit. So we're going to have to write the second answer down. So now I'm going to call 49.866 my first angle for beta. And I'm going to call 130.114 my second angle. So essentially what we're doing now is we're solving two problems at the same time. We're using the same table to do it. You could at this point split your work up and start doing two separate tables, right? But we're going to keep everything in one table. And what I like to do now is if I know beta has two answers, everything has two answers, not the given. The given is done. Don't worry about anything that was given. But write down gamma 1, gamma 2, C1, C2. And so everything that is left to find is going to have two answers. If you're kind of confused about like doing two problems at the same time, let me color code it so you can kind of see what's happening. Let's call it like the red problem and the blue problem. So the red problem, alpha is in the red problem. Beta 1 is the second angle in the red problem. And gamma 1 is the third angle. Now the blue problem, alpha is the first angle in the blue problem. Beta 2 is the second angle in the blue problem. And gamma 2 is the third angle. So yes, alpha is shared. Alpha is an angle that is shared in both problems. And then the same for the sides. A is part of the red problem, side B is the red problem, and C1 is the red problem. A is part of the blue problem, B is part of the blue problem, and so is C2. So that shows you what pieces of information are part of what problem. All the ones go together, and all the ones are my red problem. All the twos are my blue problem. And the given information is in both. Okay, so we're using the same table to solve two problems. Let's do gamma 1 and gamma 2. All right. How would I get gamma 1? Yep.
You subtract 35 and 49.886 from 180.
Now, take the other two angles that are part of the red problem, which is the given and the beta 1, and subtract those from 180. So we're going to do 180 minus the 35 and minus 49.886. 95.114. Now you could go do C1, because now you have gamma 1, so you could do C1. I like to finish all the angles off, and then I'll finish the sides off. So let's get gamma 2. All right, how would I do gamma 2? Haley?
180 minus 35 minus 131.94.
Yeah, so gamma 2 is part of the blue problem, minus the other two angles that are in the blue problem. The given and the one with the 2. 130 and 35 is 165.114. So I'm going to do 180 minus 165.114. That gives me 14.886. Okay, so now we're done with the angles. Now we're going to use those angles to get the sides. All right, let's do C1 first. Now, C1 is part of the red problem. It's part of the problem that has the ones. I need a red row that has everything in it. I have two rows in that table that are red. Bless you. Which red row should I use? A, alpha, or B, beta 1? If you can't visualize it, that's a red row. and that's a red row. Right?
I would say A and alpha because those were given to you, so you know they're right.
Yeah, they were given, we know they're right, so we're going to use 35 over 6. It's perfectly fine to use that row in both problems because it's a red and it's a blue row, so you can use it for both. So sine 35 over 6 equals, what's going to go on the other side?
Sine
95.14 degrees, yep.
over
C1. Okay, cross multiply, and there's your answer for C1. So 6 sine 95.114. Make sure you close the parenthesis and divide by sine 35. 10.419. Okay, so now we've got C1. Let's see if I can just put it right here. Let's find C2. Hold this down. Alright, so I already said you can use sine 35 over 6 again because that's a blue row. Okay, the two blue rows that you have that are complete are this one and that one. Those are your choices for blue rows. I would stick with the 35 over 6. Alright, so sine 35 over 6 equals, and Brian, what's going to go on the other side?
Sine 14.886 over C2.
14.886. Yep, over C2. Okay, cross multiply, and we'll have our answer for C2. And then we're done. So let me see, is this going to save me any time? So 6 sine, change this to 14.886. And we're still dividing by sine 35, so that's good. 2.687. And that's the law of sines where it's a two-solution case. And I don't really think it's harder, I think it's longer because you have to do everything twice. But any questions on any of the steps we had there? So what I want to do in this part, I just want you to watch it. I want to sketch this reasonably accurately. I'm not going to sketch these exact numbers, but I want to sketch a problem where you could have two solutions. Now, each problem, the red and the blue problem, shared three things. They shared a side, and an angle. So let me draw two different triangles, but they're each going to share a side, and an angle. But everything else will have different values. All right, let's take this triangle. And the first thing I'm going to do is take this side, make a copy. Does everyone agree this side and this side are the same length? Anybody disagree? Okay, just copy it. So, they share a side. Okay. Next thing I'm going to do is create another side that's the same length as the one above it. I'm going to make a copy of this one, but I'm going to flip it. By flipping it, is this side still the same length as that side? What do you think? Caitlin, what do you think?
Well, showing the sides in the 2 marks it is.
Yeah, I mean, is it really though, or are those two marks lying? Like, is it, by making a mirror image of it, is it still the same length?
Yes.
Yeah. If you just take something and make a reflection of it, it doesn't change how long it is. So if you were to, take a ruler and measure it, those two sides still are the same length. And now, I don't have much of a choice. I'm just going to connect the third sides together, like that. And does anybody see, they've got two sides in common. Where is the angle they have in common? Yep.
It's at the corner, so
And,
it's closer to the one line. If showing that like the triangles are the same.
so the one in the lower left?
Yeah.
Okay. So, yeah, if you line these up, I think you can see pretty easily that the one in the lower left is exactly the same. So what I've just done is I sketched two different looking triangles, but they each have a side, and another angle in common. This is exactly what happened in the last problem. The third sides were different lengths, the second angles were different measures, and the third angles were different measures. But the other three things were exactly the same. That's what just happened right here. Any question on that one? All right, so let's try this one.
Actually, I have a question
Yes.
about where we just were. I understand why there would be two different solutions that you can find, but at what point in the problem would you be able to tell that there would be two different solutions?
The point that you can tell there's two different solutions is once you get this first angle right here, you get that 49.886, and you subtract it from 180. If that number fits with the given number, that's how you know there's two solutions. And by fits, I mean they don't add up to more than 180. So you take that angle that you found from beta 1, subtract it from 180, and if it's small enough and it fits in the triangle with what was originally given, that's when you have two solutions. Yesterday, I think the second answer came out, it was like 160 or something. It was just too big. It didn't fit with the angle that was given. Right, now let's try this one. Definitely law of sines, because I have a complete row. And I have a row that's totally empty, and it is impossible to find something in that row. Pythagorean theorem is not allowed, so you're not going to get B. And to get another angle, you would have to have two of them to add them up and get, add them up and subtract from 180. We don't have two of them. Okay, so what do I have to find first? There are no choices, right?
You have to find the A and the.
Well, we know A is 2.
You have to use the C and the gamma to find the alpha.
Yeah.
Pairs with A.
We have to find alpha. So that's the first thing we want to write down. Okay, so set it up. And what's going to go on the left side? Gina?
Sine 50 over 1.
Yep, sine 50 over 1. Technically, we don't even need to put it over 1. Just think about it. We divide a number by 1. It doesn't do anything. But, so in this case, it's just a 1. And what's going to go on the right side? Emma?
Sine alpha over 2.
Sine alpha over 2. And as we expected, the variable is in the top. It always will be in this kind of problem. And now let's get sine alpha by itself. So multiply by 2. I'm no longer going to divide by 1 because I don't need that. So multiplying by 2 moves it to the other side. And what do I do for my last step before I type it in? Okay,
Inverse sine on the other side.
good. I'm going to do the inverse sine on each side. That's gone. And let's see what happens. So inverse sine of 2 sine 50. Right, so the calculator said that. So one of two things. I did something wrong, or it's a no solution. Oh, let's just check 2 sine 50. Don't do inverse sine. Let's just try 2 sine 50. I get 1.53. Think about the sine function that we studied last week. Put that in. Does anybody remember the highest and the lowest that the sine function went? Yeah? Okay.
1, I believe.
Yep, 1 was the highest that it went. So if you look at the sine function, that's what it looks like. It only goes as high as 1. 2 sine 50 came out to 1.53. So basically what you're trying to do when you take the inverse sine of 2 sine 50 is you're trying to figure out, actually let me type it in like that, 2 sine 50. You're basically asking where that line and wave cross each other. Where do they cross? Never. That's why when you typed in inverse sine 2 sine 50 on the calculator, you got an error. It's impossible. This situation will never happen. There is no triangle that you could ever draw from that information. So, that means this has no solution. And remember, all these boxes like to go together, so that means everything has no solution. Because if you don't have alpha, you don't have something to add to gamma and then subtract from 180. So you cannot get beta. And if you can't get beta, you're definitely not getting the side that's across it. So this is a no solution. So what would happen here is if you actually tried to draw the triangle, the sides wouldn't meet. It might look something like this. They just wouldn't connect. Any question on that? Right, so that's a no solution. So we've done the 1 solution, 2 solution, and no solution. All right. Let's see. Well, we got 2 problems. Let's pick which one we want to do. You want to do the problem about the Coast Guard, or you want to do the problem about the guy measuring the height of the mountain? Coast Guard. Okay. So the Coast Guard is kind of an interesting problem because I watched something on YouTube once with how they actually search for people or boats or whatever they trying to find, and it's pretty neat. It's not just like randomly just drive a boat out there and look around. They have a very specific thing they do to give them the best chance of finding whatever it is they're trying to find. All right, so what's basically happening in this problem is let's say we have a boat out in the ocean and they're trying to find it, and let's say it's at night, so the boat doesn't have, can't see any landmarks, so it's at night. And their engine still works, but they don't have their GPS, and it's cloudy, so they can't see any stars. So they can go somewhere, but they don't know which way to go. So they radio in to try to get some help and say, we can go somewhere, but we don't know what direction to head. So the Coast Guard station says to them, well, we got to know where you are. So you have a light or something you can put on your boat. So they have a really powerful light they can put on. They turn it on, And the Coast Guard can see like a small speck of light. They use their binoculars and they see a speck way, way out there, a little light. And they see it blinking or something. So the way this is going to work is we have two different Coast Guard stations that each are going to be able to see that speck of light. If only one Coast Guard station can see it, then this doesn't work. You have to be able to see the same thing from two different spots. And you have to know the distance between the two spots that are seeing the object. But that's simple. It's like looking up the distance between two cities on a map. The locations are known. You could just look at a map and find the distance. So we've got two Coast Guard stations, okay, Zulu and X-ray, and they are 120 miles apart. Again, the ship sends out an SOS. Mainly they're using some kind of light on their boat. They got a radio, they got the light, their GPS isn't working, so and everybody dropped their phone in the water. So they don't know where they are. So what's going to happen is each station is going to see the light from a different angle. Now think about it. If you're standing in one spot and you wanted to point exactly to something on the back wall, it has a certain angle to where you are. But then if you go over here and I want to keep pointing at it, the angle now changes because I'm in a different spot and I'm still pointing at the same object. So the way we would measure the angle is with a compass. Okay, northeast, southwest. That's the direction they would use. So the first Coast Guard station sees the boat, or the light on the boat, at an angle 40 degrees east of north. That's measured from Coast Guard Station Zulu. Now, Coast Guard Station X-ray is going to report their location. Okay, they say, all right, you guys see the light in this direction. Well, we see the light 30 degrees west of north. The fact that one station sees the light to the east of where they are and the other one sees it to the west, that means that the boat is between the two of them. It's like saying, well, if I look right, I can see it. And someone else says, well, if I look left, I can see it. Well, then that must mean what you're looking at is between the two of you. Okay, so we know that. Right, and the question is, how far is the boat from each station? All right, so the best thing we want to do in this one is we want to set up a diagram. And I'm going to set it up exactly for this problem, and then I'm just going to tweak it for a second and show you, like in a real Coast Guard problem, what would actually end up happening. Right? This is very exact information. Searching for somebody or a boat is never very exact. It's a guess at where you think they are. Right? But we have some pretty exact information, so we can do math with it. And we're theoretically going to get an exact answer, but in real life it would be a little different. Okay, so first thing we want to do is make a sketch. What's something important that's in this sketch? And I want you to think about the objects in the word problem. What are some of the objects that we want to put in our diagram? Yep.
The two Coast Guard stations.
Okay, and what else do we need to put? Because without this, we can't put the Coast Guard stations anywhere.
The boat.
Okay, and without this, we can't put the boat there. What else do we need?
Water.
We need water, and we need land. So that's the first thing I would do. I would put a line, and actually, you know what? Let me, all right, so let's take a look at what we have. So the boat is going to be somewhere up here. Okay, the boat is in the ocean. Okay, we've got two Coast Guard stations, and generally the Coast Guard station would be right along the shoreline. So let's put those in. So here's one Coast Guard station. Here's another Coast Guard station. We don't necessarily know the boat is centered between the two of them. All we know is it's between them somewhere. And now what we're going to do is we're going to draw in a line, kind of like a line of sight, straight from the Coast Guard station to the boat, from each Coast Guard station to the boat. So put in a line, we make it so you can see it. I think this will show up. Yeah, it shows up here. Okay, so there's a line, and pretend like that's the beam of light coming from the boat, going right to the eye of the person who sees it. And same thing here. So what that did is it just pinpointed an exact spot where the boat would be. Beam of light towards one Coast Guard station, towards the other. Where they cross, that's where the boat is. Now, in an actual problem, it would be a little bit more like this. The Coast Guard station would have an angle of error that they think the boat is between. Okay, I'm not going to do it like this, but I just want to show you what happens. So they wouldn't know exactly where it is, but they would have this angle of error. And what that creates is a search area. So that area that I just shaded in and circled, that might be like 10 miles by 10 miles or something. So the further away the boat is, the bigger the search area gets. And now the Coast Guard would go out and search that entire area to try to find the boat. And they have very specific patterns that they use to try to do that. But that's not really what we're going to get into. So again, we're going to keep it a little simpler, where we just have the two lines giving us an exact location. And I'll make them easier to see again. Let's make that. The green works pretty good. All right, now, the Coast Guard station sees the boat. You need to look up how they describe the angle. 40 degrees east of north and 30 degrees west of north. So the direction they describe seeing the boat is a direction from north. So what I want to do is, on my picture, put in a line that represents north. Just like that. And like that. And I want it to be right at the Coast Guard station. Right, let me make that a little easier to see. Let's try that. That looks good. Now I need to label which station is which. Which station is to the west? Is that Zulu or X-ray? Yep.
Zulu.
Okay, so this is Zulu. This is X-ray. And we were told the distance between the two. Can someone remind me, what was that distance?
120.
120. So this line that I just did in the green is 120. Okay. Now, what is the angle that Zulu sees the boat at? How many degrees east of north? What was it? Yep.
I believe it was 40.
40? Okay. This is north. This would be south. North-south goes up and down. So it's 40 degrees east of north. That would be that angle right there. 40 degrees to the right of north. Okay. Now, same thing over here. Station X-ray sees it a certain number of degrees to the west of north. West is to the left. Which angle, what was the angle that Station X-ray saw the boat? How many degrees? How many?
30.
30. Okay. So X-ray sees the boat 30 degrees to the west of north. And now The goal is to figure out the lengths of those two sides of the triangle. So let's take this. And what I'm doing is just tracing over my triangle. And I'm going to bring it down below so I have kind of a clean space to work on. Okay, so I know this side was 120. How about this angle? That would be this one right here. How much is that?
50.
50, because this makes a 90. So this is a 50. And what about this angle over here? That's a 60, because again, that makes another 90. Well, now what you've just done is you've triangulated the position of the boat by using two different observers to measure it. From here, this is as simple now as just finding the sides in a triangle. Angle, side, angle. That's a law of science problem. It doesn't matter which side you call which. You could call this side A and B. The point now is just find A and B. Now, technically, we don't have a row that's complete because you don't have a side and an angle across from it. What could I find here that would give me both the angle and the side across from it? Well, so I've labeled everything that's given, but there's one more thing I can find here pretty quickly. Yeah. I can get the other angle at the top. And I know they didn't ask for that angle, but I don't know how you're going to do this problem if you don't find it. You have to know the angle and the side across from it. So what is this other angle at the top? So 50 and 60 adds up to 110. So this angle at the top would be 70. Now you're good. Here's your angle. Here's the side across from it. There's your full row in the table. So, how would we set this up to find A? Yeah.
Sine 70 over 120.
Good. Sine 70 over 120. And then on the other side?
Sine 50 over A. Oh, sorry. 60.
60. Sine 60 over A. Let's set it up for B. Find B. Bless you. Tyler, how would I set that up to find B?
Is it sine 70 over 120?
Yep, same thing again. We want to use that information.
Then sine 50 over b.
Sine 50 over B. And what this will tell us now is once we know those two distances, we draw it on a map and we can figure out exactly where the boat is. In reality, it would not be exact, okay, but we're doing it exact. All right, so we got 120 sine 60. So 120 sine 60. And then I'm going to divide that by sine 70. I accidentally did it in 2 steps this time. I usually do it in 1. But the answer is fine. It's 110.59 miles. So that's the distance from Zulu to the boat. And the distance from, what's the other one called? X-ray? X-ray to the boat? Let's see. Since I didn't do it all in one step, I gotta type the whole thing again. 120 sine 50 divided by sine 70. 97.82. Right. So that distance is important, but something else they might have to take into account is if they can only, say, send a boat there, and the boat can go 30 miles an hour, they usually measure it in knots, but let's just say 30 miles an hour. I mean, you're looking at over 3 hours for the boat to get there. So by the time they get there, that boat might not even be where it was, especially like if the light burns out. They can't just say, well, it was here. Now they have to maybe look into, well, how's the current moving things? We should move where we think the boat's going to drift to. You know, if their engine stopped working and they started drifting. All right? But it gives them the two distances, and that's all we were interested in. But yeah, if you want to see something kind of interesting on YouTube, if you look up SAR missions, search and rescue missions for the Coast Guard, it is pretty neat how they do it. And they use different type of search patterns depending on different conditions and what they know. All right, any questions on that? All right, so that finishes up law of science. And that's the homework for tonight. It's on 267, 29 to 35 on, and 39 and 43. Okay, we'll take a look at that tomorrow, and then as long as we get through everything tomorrow, that should finish up all the material for the week. And Thursday will be a review day.